Hey everyone, Reese here, and welcome to another episode of ctrl-alt-rees, and more specifically, my SepTandy 2021 video. So, if you haven't come across it before, what is SepTandy all about? Well, throughout the month of September, a whole bunch of us on YouTube are collaborating together all over the world under the hashtag SepTandy to make videos all about the Tandy Radio Shack Corporation and the various machines and computers and gadgets produced by that corporation over the years. What it isn't is a whole bunch of people making videos about a guy called Andy, which for some bizarre reason is what my wife thought it was going to be. Now, I've covered some pretty interesting computers on my channel so far, and so you'd be forgiven for thinking that perhaps I'd want to put together a video about the TRS-80 or the Tandy 1000. But I've never actually owned either of those machines, and to be honest, there are people taking part who have far more experience with them and are far better qualified to talk about them. So I thought I would pick a subject which is dear to my heart and something that I do have a lot of experience with. And that is this Science Fair branded 150-in-1 electronic project kit, which was manufactured by Tandy and sold in Tandy and Radio Shack stores all over the world. And I happened to have one of these as a kid. So let's take a look inside and see what it's all about. So, first things first, I thought I would just give this box just a very quick clean, and as you can see by the state of this, it was very dusty and disgusting. It's probably been sat in someone's loft for the past 30 years. But here it is, the Science Fair 150-in-1 electronic project kit that I had as a kid. And I recently bought this on eBay, as I'm sure I mentioned in the intro. So let's take a look at the box. Now, as you can see, this is very 1970s looking with this kind of hand-drawn illustrations and stuff. It has an advanced integrated circuit. I don't really remember using that. I'm not really sure. I'll have to have a look at that and see what it is once we get the box open. But there's some good examples here on the kind of projects that we can build with this. So we've got communication circuits, test equipment circuits, electronic sound effects and computer circuits. And I remember as a kid I used to love the electronic sound effects and making annoying noises to wind my family up. The electronic bird, the electronic cat, and yeah, one transistor toy organ, motorcycle noise. Some of the communication circuits, I remember there was an FM transmitter you could actually build with this, and it had a range of all of about a metre, I think, or yeah, a couple of feet, if you're that way inclined. And yeah, the 7-segment display. Wow, this is really bringing it all back. So one thing I have noticed just poking around this box, and I haven't actually opened this yet because I wanted to do this on camera, is this button, this push button thing, which I presume is for like sending Morse code and that kind of stuff. You can actually see there's a reference to it here on the end of the box, on the side of the box as well, where it says code key. Now, I don't remember actually having that in mine. I think I must have got this second hand from maybe like a cousin or another relative, which is quite often the case in my family. And it probably had some bits missing, so maybe it's in there, maybe it isn't. But yeah, there weren't many pictures of the inside of this thing on the eBay listing, so let's take the lid off and see what we have here. Now, it's good to see that the manual is here. I remember this weighty tome of a project. Project catalogue, I guess you could call it. But yeah, I think they call it a... yes, on the box it has a reference to the giant lab type manual. And every project explained in non-technical language. Schematics teach theory, simple pictorial diagrams. And yeah, of course it has the schematics as well for the actual circuits, so you don't necessarily even need to build them using this kit. You can source your own components and build them externally if you want to, if there's anything that you want to kind of use in an external project. So here is the manual, custom manufactured for Radio Shack, a division of Tandy Corporation. So there you go, there's the SepTandy link there. And yeah, I had a few bits and bobs from Tandy as a kid. I had the radio control cars and stuff as well that were kind of Tandy branded. So yeah, Australia, Belgium, UK, printed in Japan, and based in Fort Worth in Texas. So yeah, real international operation this. Now, before I look at the kit, let's just take a quick look at this manual. So Yes, copyright 1976. So there you go. It's a definitely a product of the 70s, as suspected. I was born in the mid-80s, so yeah, it would have been old by the time I got one. And yeah, this Science Fair 151 electronic project kit may be your first experience with the very exciting field of electricity and electronics. It certainly was. We hope it won't be your last. Well, I'm here to tell you, Mr. Tandy Radio Shack, that yeah, 30 years later, I have a YouTube channel where I do soldering and whatnot. So, and that's probably partly your fault. 150 different experiments you can perform with this kit. We've included all that you need for all of these experiments except for batteries. You'll need 2 Type AA pen-light batteries. Yep, got those, and a 9-volt battery, which I also have to hand. Obviously, I'm not going to sit and read all that out, but yeah, so we have a relay, we have a lamp, there's a meter, transformer, a potentiometer, a variable resistor, same thing, I guess. I know it's not technically the same thing, you don't need to correct me down in the comments, but close enough. Speaker, resistors, capacitors, solar cell, yes, I remember, yeah, there was a cadmium sulfide cell, basically a light-dependent resistor, from what I remember. Diodes, and yeah, transistors, LED digital display, radio circuits, antenna coil. That was, I remember building a crystal radio with this that used that, and the key with the Morse code, which I didn't spot when I opened the box, and sure enough, it's not here. So yeah, seems like a strange thing to lose, doesn't it, considering it would have been quite a big part of the kit. And also, we've got plenty of wires and bulb holders and other things here. Even the cover for the light, you know, light dependent resistor is there. We've got the solar cell and stuff still intact. The looks like the bit that goes in your ear from the crystal earpiece is missing, but that's probably not necessarily a bad thing, considering it would have been in someone else's ear. That looks like it's had tape holding it together at some point. In fact, I think it's still got tape holding it together. But yeah, it looks like all of the parts are here and present and correct. These bulb holders, I don't remember, I think these are additional. These are the kind of ones that we used to play with at school when I was a kid. So that's pretty cool. I've got some bulbs here as well. Back in the day before everything was LED. And it looks like there's some extra bits in here as well. So there's this, which is a switch. I don't know if you can read that. Not for mains use, 2 amps. I think you'd have to be pretty brave to wire that up to the mains. But you never know. You never know. And I also spotted this interesting little circuit. So yeah, let's just hold that up to the camera there. Where are we? That, to me, looks like it has a couple of transistors and a few resistors and a capacitor. So is that some kind of amplifier? I know there were some radio kits and things that you could build with this, so perhaps whoever owned it built an external... Oh, look at the soldering on that. Wow, that is old school. Perhaps they built an external amplifier so they could make that a bit louder or something. Obviously the crystal radio is really, really quiet. So yeah, so someone taking their own initiative there, which is always good to see. Hopefully using the skills that they learnt from this very kit. So, oh, there's a couple of the wires actually connected. Let's just pull those out and take a look at what we have here. In fact, looking at this, let's not just rip the wires out willy-nilly, because these are actually connected up, or what bits are connected up are connected to the radio tuner here, and the crystal earpiece is actually connected as well. So it seems like the last thing that the previous owner of this kit built before they put it away was the crystal radio, which was one of my favourite things to put together as a kid. It's going to be a difficult thing to demo for YouTube because, like I say, it is very, very quiet, and also I think it only picks up long wave, which is probably, I don't know if anyone even broadcasts in long wave anymore. So as you can see, we've got the battery contacts here. We've got some transistors. Very interesting. We've got both types of transistor there. We've got these old school, are they germanium transistors? I think they used to be back in the 70s. Ones they use in like guitar pedals and stuff. I think they're quite valuable if they still work. We have the integrated circuit here, which looks like it says BA302 on the side. I'm not quite sure what that is. That's interesting. We've just got a couple of, it's a very basic integrated circuit, but of course for the, 1976, if you'd bought this brand new, that would have been quite exciting because, chips being relatively new technology at the time, and most of your electronics at home probably wouldn't have had them in. We've got some electrolytic capacitors here. We've got some ceramic capacitors. Nice selection of resistors. It's nice to see that they're all labelled. Obviously 100 ohm, 10k. We've got two 10ks, 220k, 100k. So you've got all your sort of common values there. Very cool to see. The little Roxanne red light. Does that still have a filament in it? Doesn't look like it. Looks like that one might be knackered. And yeah, the meter, and I think this could be wired up so you could use it as a voltmeter or an ammeter. Very, very cool to see. Yeah, the LED, used to love playing with this and making it spell things out one letter at a time. Loads of memories here. That's really cool. So yeah. So basically, if you haven't come across one of these before, and I don't blame you if you haven't, it uses these springs. So each leg of each component is basically wired to one of these springs underneath the board. And then it comes with these pre-stripped wires, which have, obviously they're tinned on the ends as well. And connecting one component to another is a case of just bending the spring, slip the wire into the spring so it grips it, and then, yeah, just straight in. Oop, to the next one, and there we go. And nice and secure, obviously easy to see what's going on, and the wiring diagrams are in the book. So let's take a look at this book and just have a look at some of the projects that we can build with this thing. And yeah, there's 150 of them. I'm not going to build them all today in this video. In fact, I think what would be fun is if I do a follow-up to this video. So if we go through the list of the projects and maybe make this a two-parter, and if there's anything in here that you spot that you think would be fun for me to build, suggest it down in the comments and I'll put it together. I think that sounds, yeah, a bit of audience participation. That's what YouTube needs. So we've got the electronic candle. Amaze your friends with this bit of electronic magic. You can blow out the lamp. The lamp candle will come on when you let light shine on the CDS cell. When the light is removed, the candle goes out. So it's a candle that only works when you shine light on it. That's not very useful, but I suppose it's educational. I think I remember building this one actually when I was a kid and probably not really understanding what it was about. It uses the relay though, that's exciting. The relay straight off the bat. The big air, oh. Now this one I do remember building. So this is a high gain 3-stage audio amplifier which allows you to increase sound levels just like a high gain hearing aid. You can use this circuit with extension leads on the speaker used as a microphone up to about 30 feet or so. With this setup it is possible to bug an area and hear the slightest whisper. Well, that is a lie, because I remember building this one when I was a kid, and as you can see there's a lot of connections here. You can see the wiring sequence. So I was very patient and assembled the whole thing, and you listen to it using the little earpiece thing, and trying to bug my sister's bedroom to see what her and her friends were talking about, probably horses, and I think she was a bit too young for boys at the time, but yeah, probably horses. And then of course you had to hide this entire thing under her bed and hope she didn't notice it, and sit in my own bedroom and listen to see if I could hear anything, and of course it never worked, and yeah, all that effort was for nothing. So I'm not going to be building that one today. The electronic reflex tester. Compare your reflex time with someone else's. And I love how they actually have the circuit diagrams as well. And if you I'll just go back to this one, because it's quite a complex circuit with some different parts, and the way it explains the different parts, we've got the 100 ohm resistor and 470 microfarad capacitor form what is called a decoupling filter. This is required in multiple stage amplifiers such as this to keep oscillations from occurring due to battery resistance. I mean, I don't even understand what that means today. I wouldn't have understood that as a kid, but I mean, it's a proper serious educational resource, isn't it? It's you could actually learn a lot from studying these circuits and putting them together. Like I say, I mainly use them just to annoy my sister. So yeah, we've got the reflex tester, the machine gun pulse oscillator. I don't remember building that one. It's the sound of a machine gun or one-cylinder motorcycle engine. Adjustment of the 50k control allows you to obtain from a few pulses per second to a dozen or so. Well, that is very interesting, and it actually uses the key, which we're missing. But of course you could just touch the wires together. I guess that might be a fun one to build. Should I have a go at building this one? Tell you what, let's put this one together because that looks like a fun little circuit, doesn't it? So, right, that's the circuit completed. Obviously I don't have the key like I mentioned, so I can't connect that, but I can just touch the thing against the terminal there, so we'll see if that does anything. So I need a battery, which I just happen to have here. Hopefully nothing sets on fire. And yeah, let's see how we go. Oh! Oh wow, how cool is that? So, I'll just unplug that. But yeah, obviously that works. So obviously what's happening is one of the capacitors is charging up and discharging, and every time it's charging and discharging, it's creating a pulse, and that's being amplified by the transistor and the transformer, just to massively oversimplify things. And yeah, it creates a pulse every time it discharges. That was really cool. And you can change the speed of the pulse with the knob. Obviously it's started off as a fart machine, and that was quite impressive. I'm not quite I think I'm not sure if that's just one of the old capacitors just settling in. It's a shame I can't get it to do that again, but you know. And yeah, oh actually I could have switched that with the could have wired that into the switch there. Anyway, so, and it says here, oh, it does actually explain how it works. So yes, electrons. So I'll tell you what, I won't bore you with the details here, but it does explain in great detail how it works electrically, and it also says to experiment with the values of the capacitors in place of the 10 microfarad capacitor, just to make it make some different noises. So yeah, maybe we could get our fart machine back after all. But I'm impressed. The old transistors and the old electrolytic capacitor still working great. So that's really cool to see. So yeah, so we'll just carry on through these. Obviously we're only on number 4. and I'm aware that I don't want this video to be too ridiculously long. Like I say, if there's anything you spot in here that you think would be fun for me to build, please do let me know down in the comments, and I will put that together in a follow-up video. So we've got the rapid LED display switching, persistence of vision test. So this is going to switch things on the 7-segment display quickly for a persistence of vision kind of effect. That'd be quite fun to see. Light oriented direction finder. This project demonstrates how outer space probes can be guided to far distant places by starlight received from a telescope. How cool is that? So that'd be like the almost work like the detector thing from Alien as well, maybe, using the meter. So that might be a fun one to build. That uses the solar cell as well. The electronic bird, that's going to be similar. The first of the special sound effects projects, that's going to be similar to the thing that I've just built, only it's going to make really annoying high-pitched screeching noises rather than fart noises. The electronic cat, I imagine that's quite similar. Do you have a cat? If not, you can make people think you do with this electronic cat. You can make meows that are so realistic that the mice will scatter. I probably need that in my house with all the live mice that the cats keep bringing in. The electronic motorcycle, that's probes. By using your hands, you can make the sound of a motorcycle starting up and going through the gears as it speeds away into the distance. And that uses the solar cell and it's squeezing the probe wire, so that like the natural capacitance of your body, I guess. Let's get a move on. The electronic insect, acoustic feedback oscillator, which is capable of making sounds. Two-tone patrol car siren, a bit of a neenaw. Electronic siren, electronic metronome. These pages have got some dirt on, so these are probably ones that they, you know, when you get an old car and you get the workshop manual with it, and you always know the things that broke all the time, that could by which pages were the dirtiest. Like you know, if like the head gasket page was particularly dirty, or the oil filter or something like that. I guess maybe that's a similar telltale sign here. But actually, this manual, considering this is what 40, getting on for 40. My maths is terrible. 1976. Is well over 30 years old. 45 years old. It's 45 years old. Yes. The electronic grandfather clock. A 2-transistor metronome. Metronome, that's quite an interesting project, isn't it? Yeah, so the transistors are arranged in an oscillator circuit, which is capable of driving the speaker directly without a transformer. That's a fun one to put together. Light-controlled electronic harp. I remember this one. This is like a theremin kind of thing, where you wave your hand over it and it makes different noises. That's fun. In fact, shall we put that one together? Let's do it. Just remembered that one of the most fun parts of building these projects is ripping all the wires out afterwards so you can build the next one. That was always satisfying as a kid. And right, so yet again, this would usually have gone to the key, which would then connect to 120, but we don't have that. So let's plug this in and see what happens. After a little practice, you'll be able to play many tunes with this musical instrument. I think this is... I'm not sure if you could describe this as a musical instrument, but... Yeah, I'm going to unplug that. I mean, I may be approaching my 40s, but That hurts even my ears. But yeah, proves that it works. I'm sure that set off every dog in a 10-mile radius. Loads of fun, that, just for annoying the hell out of people. Anyway, right, that's quite cool. Those cool little theremin type circuit. We've got the sleep machine, pulse oscillator with a very long off-time delay. So I suppose he fell asleep listening to the monotonous, hypnotising clicking sound. Lots of things that make annoying noises, which is always great for kids, isn't it? We've got the coin battery. Oh yeah, good old... I'm not really sure that's a actual use of the kit, as it's just a case of a piece of metal and a penny on a damp piece of paper, and then you just connect them to the meter. But it obviously teaches kids the the principle of a battery, and like the old lemon battery type circuit thing. So that's quite interesting. Oh, electronic thermometer. A thermometer. Basic bridge circuit which is used in virtually every electronic thermometer. Temperature sensitive element is a common germanium transistor. Oh, I did not know that. I always thought they used like a thermocouple type thing. Obviously it's not going to give you an exact temperature reading, but it will give you relative temperature readings, and that's quite interesting. Cool. Let's motor through these, because I'm taking quite a lot of time just reading all of these. We've got the solar powered light meter. Yep, that's just a solar cell connected up to a meter. We've got the slightly more advanced version, which uses the CDS, the cadmium sulfide cell. Isn't cadmium like... Pretty sure cadmium and sulfur are both really dangerous things. Probably don't want to lick that. Yeah, let me know down in the comments. Solar cell, CDS light meter, the super sensitive light meter. These are just all variations on the same light meter, aren't they? The sonic fish caller. For many years, fishermen have looked for ideas that will help them catch fish. Then some scientists and biologists found out that fish and other marine animals communicate with sounds. They don't talk, obviously, but they can make sounds that represent danger or other basic responses. Scientists found that some fish respond to certain sounds with curiosity. And so the fish caller was invented for fishermen. This circuit is similar to some of the fish callers being sold today. There you go. I bet, big corporate big fish caller probably tried to cancel this project because it was eating into their sales. Hydrometer, that's for measuring dampness for relative humidity in the air. That's for you can buy those for your house plants and stuff, can't you? So a lie detector, that'd be fun. Oh yeah, so that's your typical sweat detector. Rain detector. Yet again, these are all different sort of variations on a moisture detecting theme. Metal detector, that might be a fun one to build. So that uses the actual radio circuit. An accelerometer. How does that? Oh, the rate of change in the rotation knob. So how quickly you turn the control knob. That's clever. Just a basic 7-segment. How to play with the 7-segment display, just using some batteries. Basic LED display. That just lights everything up when you press the button. So yeah, 150 projects in here, but obviously a lot of them are kind of variations on the same kinds of things, but no complaints there. Obviously they kind of start with the basic version and build on that. So we've got a few things using the 7-segment display. Graphing of variable resistance using the meter. Resistors in series and parallel, so obviously teaching you about how resistance is affected by whether you wire the resistors in series or in parallel. That's very useful stuff to know. I guess there'll be a resistor ladder type thing at some point. Capacitor as a spark suppressor with the relay. I don't know why I'm so impressed by the relay. I don't know. Capacitor charge and discharge, that obviously demonstrates. I remember actually building this when I was a kid and learning about how capacitors work and how they, you could watch it charge up and then slowly discharge using the built-in meter. So, yeah, I do remember that one. A transformer experiment. Oh, that sounds educational. Generation of electrical energy. How? Oh, okay, so it uses the speaker as a microphone, and when you make loud noises near it, it obviously induces a current in the electrical coil in the speaker, which can then be amplified and show up on the meter there, so that's quite clever. Again, I think that's probably something that I learnt from this actual kit as a kid. We've got the high voltage generator. High voltage, that sounds exciting, doesn't it? Circuit includes a speaker which will be a reminder that the circuit is operating. Safety first. HV generator, so how much voltage does it? This may not be able to fire a spark plug or cause a shocking experience, but it gets the point across. You will no doubt want to experiment with this circuit. It can be made to generate higher voltages. Have fun. Yeah, wow. Again, probably one that I tried to modify to electrocute my sister when I was a kid. High DC voltage generator. DC, yeah. 90 volts. Wow. But that would be a bit of a tingler if you licked it. Capacitor discharge, high voltage generator. Yep. Diode action or diode switching. So we're starting to get into basic semiconductor circuits. So kind of logic and that kind of stuff. I think there's quite a big section on like logic and transistors and stuff in here. Yeah, transistor circuits. A voltage regulator, a regulated power supply. Regulated power supply. That might be a fun one to build, to see how well that works. Very interesting. I need to learn about power supplies because I don't think I know nearly enough about them and about how they work. Voltage regulator circuit. A comparator. Anyway, we're only a third of the way through. Logic circuits, logic and OR circuits, obviously basic logic stuff. Very useful to know. NOR, I mean this would have been the beginnings of me kind of learning basic logic, you know, kind of TTL stuff, transistor. Wow. Got logic tables and everything in here. Truth tables, that's very cool. That's very cool, isn't it? So we've got reset, set, flip-flop, a one-shot multi-vibrator. Yes, all right, no sniggering in the back there, please. We've got the flip-flop LED display. Purpose of this project is to see how a display readout can be controlled by a free-running multi-vibrator or flip-flop, so like an oscillator circuit. You know, like Luckman No Computer, the kind of stuff that he builds. His synthesizers and stuff. Multi-vibrator, speaker, microphone, transistor, amplifier. I remember building this one, the amplifier. It wasn't very good, but it proves the concept. Very cool. And yeah, it says to connect the earphone at different parts in the... So because it was like a multi-stage amplifier, you could actually connect the little earpiece thing at various parts in the circuit, and it would be louder depending on which part you connected it to as you went through, which is a really good practical demonstration of how that worked. Hearing aid amplifier, 2 transistors. Got various types of amplifier, that's very cool. Coin battery audio oscillator. Oh yeah, audio oscillators, very cool. Wow, oscillator for turn off delay. Temperature sensitive audio I'm going to build some of these. I'm going to make a video all about audio oscillators, I think. Capacitive charge oscillator. 2 transistor. We're still only halfway through. In fact, we're not even halfway through. Push-pull square wave oscillator. Micro power solar cell oscillator. So we've got various different types of oscillator here. Let's just skip ahead a bit. The thing is, they're just also fascinating. Light controlled switch with solar cell. Sensitive light controlled switch. So we've got light controlled switches. Voice controlled switch. Voice operated relay. Electronic touch switch. Okay, fair enough, it's a typo. We can forgive them for that, can't we? Transistor switcher, voice controlled switch, electronic relay switching, a latching circuit. That's handy. Useful thing to know. Super sensitive relay, relay light flasher, transistor delay circuit, delay switching circuits, lamp blinker circuit. Oh, I wish I could spend some more time on some of these. DC to DC converter. I'm definitely going to do this. Mechanical chopper, DC to DC converter. Momentary on-call switch. Momentary on circuit, which is... Oh, momentary on-call switch. I get you. Wow, in one position of the switch, the capacitors are charged by current, which must flow through the relay, and in the other position they are discharged by having the current flow through the relay. Capacitance used is high enough to keep the relay energised for about a second. So yeah, wow, you press the button and it stays energised for a second. The crack of dawn alarm clock, the daylight bird or early bird. These are very annoying things that I could have built as a kid to wake the whole house up at 5 o'clock in the morning, and I probably did. Closed loop burglar alarm. I remember building this one, and putting it on my bedroom door, and when the wire is opened or broken, the lamp lights. I remember. Water level alarm, light operated wireless burglar alarm, high power alarm oscillator, a relay and speaker buzzer, more buzzing things, light receiver light alarm, acoustic light alarm, sound activated alarm, radio signal indicator, code sounder. Oh, I see. So literally, you connect the key up, the Morse code key, and click, 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 turn the relay on and off. You can tell, can't you, that I'm fascinated with this key that I never had as a kid, and that I also don't have now, and the great injustice of not having access to this important piece of equipment. Single wire. Oh yeah, single wire. I remember building this one as well. It's like uses 2 transistors in a circuit which can power an earphone connected at the other end of a single line a long distance away. A single line is all that is needed because the earth ground may be used as the second conductor. The tone is composed of pulses which have a fundamental repetition rate of about 1600 cycles per second, or hertz. So it can be used to send code messages to a friend who is at the opposite end of the yard, or you could just shout at them, but that wouldn't be educational. Or it might. Code practice oscillator tone control, Morse code. Phone ringing at the other end of the line, a clucking chicken, a scolding squirrel, a motorboat. Everyone loves a motorboat. Solar powered code practice oscillator. Crystal radio, I think that's the one that was actually built when I got this kit that I ruthlessly ripped apart without even trying it. That was one of my favourites as a kid. Nice, good old-fashioned crystal radio. Transistor diode junction radio. Light activated radio. I think they're just combining one transistor radio with diode. Solar powered radio. Various radios that you can build. 2 transistor radio. I remember building the transistor radios. They were quite cool. 2 transistor radio with transformers. So you start with a very basic crystal radio, and then basically add more amplification as you go along, and it turns into a more sophisticated thing. And it's the way that it builds is obviously very educational as to how these things actually work. Spark gap transmitter, wireless code transmitter. So this one, you could press the button and it would interfere with all of the radios in the house, because it was just kind of make an annoying clicking noise, which was fun. As you can probably tell, I mainly used this thing to annoy people when I was a kid, because I was an annoying kid, if you hadn't guessed already. A wireless broadcaster, most basic AM transmitter possible. Yep, I remember building this. I remember transmitting to the other end of my bedroom, because it literally had a range of about 2 meters. And trying to work out ways to make it more powerful, and thinking that the police were going to show up and arrest me for broadcasting pirate radio illegally. That would be a really fun thing to build. I think I'm going to build that one. Tone modulated transmitter, solar telemetry, radio signal, basic continuity tester, oral continuity tester, series type ohmmeter. I remember building these. Shunt type. Stone bridge circuit. Well, been around for over 100 years for measuring resistances, so it must be a good circuit to have survived this long. Virtually all instruments available today for measuring DC resistances with extreme accuracy are Wheatstone bridges. Oh, look at that. That's very cool. That's like I suppose it's like a bridge rectifier, isn't it? Only it's got resistors rather than diodes. But I suppose that's where the bridge part comes from. Wow. Aren't we all learning about electronics today? Capacitance bridge. Battery voltmeter tester. Oh yeah, basic voltmeter. Audio output meter, yeah, low frequency response, audio level meter, VU meter, meter amplifier, an AC voltmeter, yeah, encourage kids to play with AC voltage, why not? Transistor checker, semiconductor tester, sine wave audio oscillator. Oh, I tell you what now, wouldn't it be fun to put one of these together and hook it up to my oscilloscope so we can actually see the wave and see how accurate it is. Well, there's a great idea for a video. Twin T audio oscillator, variable audio oscillator. So we've got a powerful audio oscillator. Oh, I like that. Power, a loud 2-transistor audio pulse oscillator. Could be used as an alarm or warning signal in high noise areas or a signal source for troubleshooting. IC oscillator / component. That's one thing that we haven't really seen much of, is stuff using this actual integrated circuit that the box was shouting about so much. That's the first one I've really spotted in this book, which is use the integrated circuit as an oscillator. Do you recognise any correlation between resistance and frequency? Between capacitance and frequency? Try it across the CDS photocell while changing the light level on the photocell. Fascinating ideas. Audio signal tracer, a radio frequency signal generator, a wideband untuned RF signal tracer, and the RF energy detector with LED display. And plenty of spaces to write your own notes as well. Oh, I see. And we've got the index here, which is sorted by project type. So natural science projects, radios, test equipment, entertainment circuits, basic electronic circuits. So yeah, you could learn so much just from putting stuff together from this kit. And yeah, just reading the notes and kind of experimenting with them. So you've got a list of components here if you want to build your own at home. So yeah, the wires are all colour coded by length. Well, there we go. Well, there we go. That's a really cool piece of kit, that is, and that's given me loads of ideas for stuff that I can put together with this in perhaps a series of follow-up videos. So yes, I mean, if you've spotted anything in there, do you think I could build with this, or anything else that you think I could try out? Let me know down in the comments. But I think for now, obviously we've had some fun with some silly little circuits here, making some very annoying noises. How fun is that? So I think that's enough, and yeah, back to me in the studio. So thank you very much for joining me on this trip down memory lane. And it really was a trip down memory lane for me, because I just hadn't even thought about some of these projects since I was a kid. And if you have similar memories, or perhaps had a similar kit as a kid, please do share those down in the comments, because it's always great to chat to like-minded people, and I always enjoy that aspect of putting together these videos. So if you enjoyed this video, please do consider giving it a thumbs up. It helps me to increase the visibility of my videos and helps me to grow my channel. And if you're not subscribed already and want to see more of this kind of thing, plus my vintage computing and retro gaming stuff, please do consider subscribing to the channel. So finally, check out that SepTandy hashtag down in the title and in the description for more videos all about Tandy throughout the month of September. And I'd just like to thank you very, very much for joining me, and hopefully I'll see you again soon.